Hello and welcome to another weekly live stream. We missed last week, so it's been 2 weeks. So we've got a lot to cover. Hopefully we can get a lot done tonight. And without further ado, let's go ahead and get started. Yeah, so there's the patrons scrolling by in the lower left. Patrons are awesome. Do you think you will let the mods climb and do things ladders one day? Absolutely. In fact, ladders were on my list of things to tackle today, but there's an issue, so I'll go over that. Yeah, so things get a little complicated. Anyway, thanks to the patrons that are scrolling by. Up in the upper left corner is the download link for the game. I checked the stats earlier, and it looked like quite a few people have downloaded the latest release, which was on the 7th. So yeah, we've got 6 of the Windows downloads, 7 of the regular, and 2 of the platform independent, which one of them had to have been mine to test it out. So that's all good, and real quickly I'll go over, this is the sort of things that went into that version. You know, the indicator when the screenshot is taken, that's this guy that just whoosh. You can select your clothing during character creation so you don't enter the world in your underwear, basically. And you can improve the, so there's just a bunch of other stuff that was fixed too. Give it a try. We're not going to be doing anything with Mythruna today. We're going to be playing with the other thing. But I want to show you guys something. We're going to hop back and forth from application to application today. One of the things we were working on before, and I know you guys love this, so we'll get that out in a second, was the stepping up, which I got working. I'll show you. It's not done correctly, and I'm going to fix that probably not today unless ramps go really well. But it occurred to me what the issue is, and so a whole bunch of issues, right? And eventually I'm going to have to start tracking. So let me make sure I cover everything. So let's see. Issues to talk about. Let's see. Bullet. Pathfinding. Uphills, that's a big one we're going to work on today. The ray collisions, not as good as I remembered. Need actions for step up, etc. So I'll make sure to just cover all these things and how I discovered them and so on and so forth. So let's go ahead and get the simulation loaded and we'll play around. I added a bunch of new visualizations. You'll see immediately that the collision for Mythruna Girl is quite a bit different. So it occurred to me that I have this block shape that I'm using as the probe. You know, when she walks, that extends in front of her. And so I changed, so according, based on some comments from somebody named Zuegg, Z-U-E-G-G, on the Discord server, which, by the way, I encourage you to join, it occurred to me that I can actually create a more complicated collision shape rather than worrying about like all these different side probes and things, forward probes and whatnot. We get a lot of information out of this if we just pay attention to which block hits what. So right now, as far as turning away from things, if it hits one of these red blocks, you know, on the sides, she'll turn away from it. If it hits the orange blocks, it's kind of contextual because she could be stepping up on something or she could be glancing against a fence or something and want to turn. These 2 blue on the side tell me when she's about to fall off an edge, and the pink in the front tell me when she's either going to be stepping down, like there's no ground in front of her, or there is a step up coming. So between these 2 pink and this orange, I can tell when she's about to step up. Now, that only controls whether she tries to steer away from something, because that was problem 1. When she tried to walk into one of these, the probe was telling her to steer away, so she would never get close enough to actually step up. But the probe won't tell me to step up because she actually needs to be at the right at the point of intersection before she steps up. But let's just arrive here. So this is the simplest, no pathfinding at all, just her normal behavior. She'll hit this and she'll kind of step up, right? That's the way it's supposed to look. Basically, eventually she'll have like a step up animation, and that'll be what we get. But let me show you. So we got like all these cool visualizations. The other thing, Zueg, I hope I'm pronouncing that right. The other thing that, oh, you know what? I don't have my chat window open. It's going to be hard to watch the chat without the chat window open. Okay. Hopefully it updates. Yeah, okay, there. Okay. So, so I widened the lines, and I can actually, if you guys can see these okay, that's fine, but I can actually make them much wider. So let's, not there, let's put the top. Like up here, I can set the line width to 4, so you guys can maybe see these lines a little bit better for all the little collision guys. You know, that way YouTube's compression doesn't make them go away. All right. So what I'm going to show you is sort of, I like having all this stuff because it shows you what's going on. By the way, these green arrows pointing down on the sides are showing me that these blue blocks are detecting ground next to her, so she doesn't have to turn away. We'll talk about the wandering around corners and stuff, which is kind of cool. All right, so I'm going to pause the simulation, and I'm going to go arrive up here, and then we'll step, 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 step as she walks up there. I probably could have made her a little closer before we got there. But you'll see, like, she won't turn away. Like, she doesn't get any collisions that tell her to turn away because they're not hitting this, and they're hitting directly on. You can see that she's got a, you can see that there's a collision right here. This orange block is colliding with this block. And so, but that's an orange block, we don't care. These blue blocks are colliding with it, we don't care about those. So we're going to keep walking towards there. Step, 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 step. And now we're getting an up, because we're far enough along that we get an up collision there. We're going to step, 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 and eventually one of her feet will hit the wall right here. I don't know if you guys can see that very well, but there's a yellow arrow here because her foot just hit that. And so when her foot hit that, I cast a ray down, and we've got this little green box here, which I should probably make bigger when the line width is bigger, that shows where we collided. And so that's basically saying, okay, we found that her foot hit something, we cast a ray down, we detected something she could step up onto. We already knew this area was open, so we only had to cast down from about there, and so she could step up here, and so now it will engage like an upward force to get her to climb that while she's got this contact in place and while she's got that collision that she's detecting that she can step up to. So that's all good, and then she'll walk forward, and then she's back on track to get to where she wanted to arrive. And so all that's working, but the problem is that the continuous nature of that means that anything that confuses the collision system, so if for whatever reason she got bumped back a little bit and her foot's no longer contacting the thing, she'll drop down, and it doesn't really reflect what needs to actually happen, because what should really happen is when she detects that her foot hits this thing, she should enter a step animation, like an action that says, I am going to step up here. Or if this is a ladder, I am going to climb the ladder. These are going to be different animations, and so there needs to be like an action associated with them that like locks them into that mode until that action is complete or interrupted for some reason. So it's no longer a question of, you know, frame-to-frame physics forces at that point, although that's the way it'll be implemented, but I won't be paying attention to all of this stuff. She'll just go through the motion of stepping up there. We already know she has the space to step up there because the probe said she does. And the context says she does. So that's something I'll have to add, and I'm going to, so that's the need actions for like a step up. So some kind of action activity, something we can put in this code here, this the code that runs every frame for the update body. So like up at the top here, we could check, is there an activity or an action in play, and just basically call its update and ignore all this other stuff until the action is done, and potentially chaining actions too, and so on. So that's one thing. The other thing is I discovered when I was playing around, because I had planned to get all this done and work on something else, but I was sidetracked a lot these last 2 weeks, medical things and other things. So, so pathfinding up hills. When I was checking that, I realized that ray collisions are not as good as I remembered. So, and we can simulate that by warping her over here. And let me move the camera. Doink. And doink. Okay, so so what I'm going to do is I'm going to get her to I'm going to have to move up. I'm going to get her to try to arrive here, which means she's going to try to clip this. In fact, I will warp her even more. So I'm going to get her to arrive over here. Right, we're going to want her to arrive over there, which means she's going to try to clip this wedge. And we'll see it. Look, she thinks it's something she might be able to step on up on, so she casts a ray down. And I'm going to show you. What I hoped was it would hit the ray and it would give me a proper collision intersection, but I'll show you that that does not happen. So step, 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 step. What we talked about before. She's going to, man, I love all this debug information. It's really cool, especially in the frame by frame. Okay, so eventually her foot, probably right about here, is going to hit that. So she gets that, right? We cast a ray down, and it's interesting. We didn't even get the collision. Oh, yes, we did. Here, this is where I need to make that block bigger. You guys probably can't see it really well, but there's a little green box here. In fact, let me find that little box. Box. Climb points. That's it. Let's make this bigger. I'm going to have to reset her little pathing thing here. Resume simulation. Okay, so let's put her right back over here and pause the simulation and have her arrive over here. Oops. Okay. And then step, 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 step. Okay, so when her foot hits the, give me a second, it's going to hit right there. So it so again, we see the yellow contact arrow that you can see there, which meant, okay, we're going to cast the ray down and figure out what we can step up onto. But you can see we cast the ray down. We didn't get our collision here. We got it up here because that's where the block is. And so as soon as I saw that, I'm like, oh, I don't think I ever implemented proper ray collision. And I was sure that I had, because I was pretty sure in Mythruna, if you try to click a block behind a wedge, that you can, which means that it's properly doing the ray collisions with these, but no, and in fact is not. And I will show you, I will prove it, because I have another tool that I use to make the blocks, and it has that kind of debug test built into it. So if we come over here, blah, 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 this should be faster. Alright, so if we go over here, there's this colliders test, which just loads a bunch of stuff. I can preload things that I want. And so here's like a version of the, oh, I can move it around, nice. So here's a version of a regular wedge, right? And I can do this sort of mouse capture mode, which lets me cast a ray from my mouse position, and then I can hit the space bar and it pauses it again. So we can see what that ray looked like, and we can see, yep, it actually collided with the outside of this box, not the face. And I think that's true even for like easier things like the cylinders. Like if we go over here, I think that it's also, yep, it's just doing box capture. So that is something I have to fix, and I seriously considered doing that on the live stream for tonight, like just doing the math. The math for intersecting the wedge part of this wedge, once we already know the block is hit, figuring out whether it hits this face or not, or hits one of these sides or not, could be interesting math, and I believe I could probably diagram it out to show you guys how that worked. Basically intersection with a line and a plane. But I wasn't sure. sometimes when I'm doing the live stream, I'm not that great at math, and sometimes when I'm doing the live stream, that part of my brain's not working right, and so I just was worried I'd get in this loop of things not working. But if that's something that interests you, I'm not going to work on that well, I don't need it right now, because another problem occurred to me that I'll talk about when I get the other tool back open. But if that seems like something interesting for a future live stream, leave a comment in the video or in here or any other way you would prefer to contact me. All right, so let's go back to our actual visualization thingy. And I'll talk about why the ray collision wasn't going to be enough. And we kind of touched on this, and this is another part of the discussion on the Discord server, which again, if you go to this link, even if you don't download the game, if you go to that link and enter the password dragon, that is where the invite for the Discord server is. Eventually I'm going to put it right in the game too, so that's easy to get to, but I highly recommend you, if you're interested in discussing specific algorithms, that's a good place to go if you don't feel like chatting here, or you weren't watching the video live, or weren't watching the live stream live. I guess it's not really a live stream if you're not watching it live, but you know what I mean. Okay, so how to show what I'm talking about. Okay, so like right here, if I create her down here, and how do I best show what I'm talking about? And then I try to get her to walk up here. So we'll just do the arrive directly. Right, arrive right there. Oh, so she walks. Okay, so I screwed up because I meant to pause it. So arrive back down here, please. Yeah, she won't walk off the edges now because she's got that detection so that she won't walk off the edges. I'm not sure this is going to show what I want to show anyway, but let's move her down here and then pause the simulation and have her arrive up here. What I'm trying to show is that if she approaches this step and she's right here, her foot will hit here, and if she drew that ray down, it will collide right here, but because it's way over near this edge, she technically doesn't have the room to step up. She needed to step up over here. So for one thing, a ray is not a great collision shape to use for that. It would have been if it gave me all the right normals and things, but as it turns out it doesn't, so suddenly it's suspect, and I can go back to doing these sorts of block shapes, which will give me good enough information. But I'll kind of show you what I mean. Let's see if we can get it to show you. So her foot should hit right. She's going to turn away from that first. Okay, so her foot should hit right here. So I can't get any closer, unfortunately, but you can see how the step up green box is right there, which is really, really close to this edge. Now, if there had been another block right here, this would look like she could step up, but she actually can't. So I need to, when I'm looking for these step up areas, I need to use a shape as wide as her, basically the same width as these boxes, this 0.25, or they 0.5, they're 0.5. So I'm going to need to use a different collision shape for that. But anyway, so that is the, so that's the ray collisions not as good as I remembered. And finally, there's a couple problems with pathfinding up the hills. So first of all, let me get her to arrive back here. We'll resume the simulation. So even if, first of all, pathfinding doesn't work up hills. Like even if we're right here and I say, path to up here, and then step, 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 it will never find its way up there because it doesn't know how to climb the paths. Whatever the step up stuff that the pathfinding is using is never going to find its way up there. And then even if it did, and she tried to arrive up there, she's just going to walk forever, and the forces don't let her walk up the hill. I mean, they kind of do if they detect it as a step up, and so like she'll bounce up because it for a second detects that it's like a step, and then because of that other collision problem, right? Her foot will hit just right, and it'll get that this is a step up here, and she'll jump up there. But that's not the right way. And so then I even thought maybe, yeah, so she won't go down because she won't fall off the edge. So then I thought maybe if I put this this shallower ramp in, perhaps she will walk up this. And she tries, like every now and then she'll get a little bit of head of steam to go up. So there's two problems to solve. One is, to get the pathfinding to go up there. Yeah, so it's like as soon as she starts to see it as jumping up, when she's partially off the edge, she'll figure it out, but it's not right. That being said, things that do work after last time, because like last time she wouldn't even step up on things, but now if we were to like path her up to here, step, it's not going to go up the ramps, but it will go up the stairs like before. And so once she's got a path, we tell her to walk the path, and she will make it up the steps. It doesn't always look great because again I need to change that activity thing, but she does make it up. And at the end of the day, yeah, so see, sometimes it looks a little janky as she tries to walk up these places that are too high for her. And at the end of the day, even if the NPCs look janky but can navigate the world, I will call that a success, and we can move on with some other things in the game and just consider that something to tweak over time. I mean, plenty of games have had janky physics and pathfinding, right? But right now the NPCs cannot walk up a single block, so anything would be an improvement. Alright, so next we're going to work on pathfinding up the hills. And this is where I kind of wish this tower wasn't here anymore, but let's just zoom in. Fortunately, this is something we can repeat over and over again. Okay. So another thing we can do is turn off the ground test. We'll leave the contacts on. Probe contacts, probe shapes. So we can turn all this stuff so we can just see what she's doing, right? Clear out the cruft. Okay. So what we want to do is mess with our pathfinding algorithm again to make sure it can traverse up. Let's see. I need to just be, I've said this before, I need a little button to just recenter on her, the camera. That would be so much easier. Okay, so we just need to get that pathfinding step-up stuff to detect the ramps. And I even have like a steep ramp over here that we could try. She's not really supposed to be able to walk up those, but okay, so that's like our, if it finds the path up here and doesn't find the path up there, we can consider that good. Also, for the programmers and the JMonkey users in the audience, or some measure of those in between, if anybody's ever interested in drilling more into how I develop these tools, I can do some potential live streams on that, just pulling one of these apart, maybe building a simple tool from the ground up to show kind of how I do it. Alright, so now we want to go back into the pathfinding stuff, which I think is even a separate file. Path actions, and path data. Okay. So these are all good, and we want to find where we do the path 2 stuff. Alrighty. And this is, I think, the step, right? The find path. Okay. So we do some number of iterations each time, which I think currently I've set to like 10. And I'm remembering how we do this, right? Each direction. So when we have her sitting here and we're trying to path to up here, you know, I do a step. Let's actually set this back to 1. Where's my step size? My iteration count. It's a trick in editors. If you click on the line you were on, you can move all over with the mouse wheel and then just move a little. So here we can set it to 1. Okay, so it's going to make me reset the path to up here. And so if we step, we can kind of relearn what it's doing. So in this case, it's telling us it's starting here. It sent steps out in all the directions because it could. And now those are going to be future candidates, which will get this little pink thing. And so we'll see it as I step. It'll try each one of these. And so that one could go in this direction, but could not go here. You can see the red through the wall, maybe. Basically, that path was blocked. And so it's going to try one of these other ones. It's basically going to try the best version so far. So it actually might try this one next. Yep. And then it found red in all directions, which is not really right. It should have checked up. But it could be that my collision test is only checking half blocks. I wonder if I'm doing ray collisions here. No, that couldn't be because we found that they won't work right for other things. So already it's wrong because this should have been up where it collides. Not down here. It should have been up to show that it's a up. So that is problem 1, is that it did not detect that this was an up. And then I think once we fix that, it may fix the other things too. But anyway, as I was saying, you know, to remind everybody, it tries each of the best candidates it can find. So eventually it's going to try that one too, yeah. And now it's going to get lost. It's going to just keep looking around for the best because it can't go the best way. And eventually it'll get all the way here. It'll fail to go up that one too. Well, it should. Oh boy. Okay. Like, this is why it's kind of fun to have it set, do like 10 at a time, because you really see it branch out quick. But so eventually it made it to here, but it's not going to be able to go up the ramp. Yeah, for the same reason, because it doesn't actually raise the height of the little probe thing it's doing. So clean the path. Oh, another thing I wanted to talk about that I need to fix is, like if we have her over here and we path to up here. Oops. Yeah, again, I need to fix that. All right, so if we path to here, oh man, I really need to set back to 10. All right, so eventually she'll find her way up that, yeah, so she finds her way up the steps and we'll build a path. But yeah, no, it does what it, I kept thinking it was trying to clip this corner, but it doesn't. It's the pathfinding that clips the corner. And so I need to like, what she tries to like walk diagonally through this area here, and it's because when she walks the path, like this ball is ahead, and so it's already trying to turn her, and so that's more of a predictive how far we can move the little ball kind of thing. So let us clear in the path, warp her back to here. Oh boy. Now you want to arrive over here. Oh boy, oh boy, oh boy, oh boy. Path to here, yeah. There we go. Clean the path. Okay. Path to up here. Step, 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 step. Now we're actually, let's warp her closer so that we don't have to wait as long. Now path to here. Step, step. That's where it's already failed. right? So we need to make this do the right thing. And so that's in this iteration here. We go down and we go in each direction of the 8 cardinal directions. And for each one, we query contacts with our shape, which is a character shape, which is, oh. Is that character shape different than the other character shape? Yes. Okay, good. So this is just a stack of single blocks. I was worried it was our big, fork-shaped one, which is actually really bad here. We want this one to just be a stack of blocks, so that's good. So yeah, we query in whatever place this is, we query the contacts in that direction, and for every contact we find, we add it to this results list. And if the results is not empty, meaning there's something there, we go through the contacts to decide if it's a contact we care about, like does it block the way or not. And are we not showing the contacts? Show contacts. True. Let's make it true. Oops. Okay, so now we at least see what contact it got. Path to here. Step. Okay. Well, I can't go any closer. That's as far as I can zoom. Ooh. No, it's not. I just have the wrong keys. Okay, so we can see it did get... Oh, it's like weird to see through the back of her head. So we can see it did get these contacts. And they are a ramp. And so we detected that they were facing up. Like here, we're going to check the normal. Yeah, so here we check with up. Is it something we can stand on? It probably was. Was the vector greater than... Yeah, so was it greater than 0.6 meters below us and less than 0.6 meters above us, so basically something we could step up onto. And so if it is, which it is in this case, so it's not blocked, but we may need to adjust our step offset. That seems like it's not being done correctly, or we're not drawing it in the correct place. So let us track neighbor offset through here. So I believe we hit here. Let's just put a print in contact but can stand. I want to say CPCN. Okay, let's set this up again. Back it up a little bit. We want to path to here again. Once more into the breach, I see. Good luck. Yeah. Indeed. Okay, so right here, one of these will tell us what we need to know. Okay, I just zoomed, so I got rid of a bunch of stuff. So contact but can stand. We are standing at 6. So I believe this is positive X, so 6.5. Yeah, 6.75. Contact but can stand. They're all right at 4. No. Something is wrong. Okay, so no, these are the ground ones. These are these two with the these two right here. Basically, this is the Y position at 4.1825. It's just we are standing on the ground is 4 meters, 4 blocks, and so 0.1825 up from that. So we are getting a good contact, and we are getting that we should be able to stand on it. Good. That's why we're not blocked immediately. But for whatever reason, our neighbor offset is not getting taken advantage of. Well, let's see what the rel vector is. Maybe rel vector is wrong. Because I think we don't track our actual feet. So, path to here again. Okay. Step, step. Okay, we should have gotten what we wanted. These right here. Rel Y is exactly what I would have expected it to be. It's positive 0.1825. Okay, good. So we've confirmed all that's working. What do we do with neighbor offset? It's not blocked. Do we... Neighbor offset equals that, or that, or that. This is what the issue is. Because we've divided the world up into a grid of half blocks to do our pathfinding. And in the XY that's probably good, but in the XZ that's probably good, but in the XY that means this isn't high enough to kick up to the next half block, so it stays in this half block. And so by the time we get up here, what we'll see is, right, we've already got these that did not go through. So this contact but can stand is the one next to us. That doesn't count. Yeah, we're not logging the other ones. But these show up as red, and it's because they're too high, I think. We can check. So, we got this. Yeah, so air color red. Red means it's too high, yeah. So, contact, but too high. And we can print all the same things. Okay, so let's do this again. Go over here so I can path to here. Boink. Step. Step. Okay. We should, yep, didn't get any. Step again. We're gonna move over here and we'll get 2 of them. Like, oh no, we're gonna actually step over there. There we go. Alright. So we get at least 2. Yep, contact but too high. One of them, 2 of them are these. That's these 4.6825. And the other one is like way up here. That's these 2 up here, which are definitely way too high. But this one looks like we're trying to step up more than half a block, which we are not. Partly, yeah, that's got to be the way it is, because we don't want to step up on like a full block height. So I'm wondering if I can change the grid resolution. I'm going to double check and see how I'm doing this. Somebody's making food. Fortunately, I had a snack, and so I am not hungry. Where do I convert? Path cell to world. Yeah. So I need to look at these functions that go to and from the grid. Oh. They are over here? No. Where'd they go then? There it is. Yes, so... Yeah, so I'm using a straight scale. So this is the issue. Essentially we've divided every block in half, but we've done it in the X, the Z, and the Y. And I would like to do it more granularly in the Y, so that we can walk up ramps. I believe... Yeah. This is going to need to be different for each type of character, because for a flatlander, characters that can just walk on flat surfaces, it needs to be like this. For characters that can fly in any direction, it needs to be even like this, whereas characters that are flatlanders, they would need a much smaller scale in the Y. So let's change these. My Math D library has a grid class that I should really be using for this, because the grid class you can divide up space any way you want. I think the reason I didn't is because, yeah, the grid class only works on whole numbers. That's why I didn't. I remember now. Alright, so we want to replace all of these with this. XC path to world scale. Replace, 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 replace. Okay. Yeah, so that's basically adding a half block. Okay, and so then we want another one. That's the Y version. So for that one, let's make it... I wonder if a third will work. Anyway, let's divide by 4 for now. And so... let me see if Vec3D has a mult that takes 3. I think it does to do vector multiplication. As 2 that take vectors, it does not have one that just takes 3 values. So that's actually not that's not awful. What I can do is I can go back to the original world to path scale equals new vec3d xz world to path scale y world to path scale and xz world to path scale. So now we've got a vector that'll do it. And so instead of multiplying by one scalar value, we can multiply by the whole vector. And we're going to want to do a similar thing for path to world scale. And that one is this one. So XC, yeah. Y path to world scale. Oops. And so then for all of these, I can multiply by that, and then do this dot x, this dot y, and this dot z. I hope you guys understand what I'm doing here. You know, we've divided the world up into close you. I just want to do stuff. You know, if you see these grid line here, this is like if these were the 1 meter blocks. We've divided up the world. So if this is you know 2 by 2 section of blocks. Looking down, we've divided the world into half of that to do pathfinding, and that's so that we can, still find our way through, doorways that are only half a block wide. Like, we can still find our way through things like this because our pathfinding is done on this smaller grid. But from a vertical standpoint, if we have a ramp up like this, and we've only divided, in half, then when we are here in the center of this block, we're stepping up, but it doesn't look like it because we're still in this grid cell. And so then when we try to step up to this way up here, it looks way too tall, right? It looks like it's way too big because it's not actually from there to there, it's from here to here, and that looks way too big, whereas this would be a more normal, less than half a block height, right? And so what I'm trying to do is leave this divided in 2 like this, and then divide this in 4 instead, so that we get some more granularity in our step up. And that's what I've done by basically changing, what we scale in X and Z versus what we scale in Y. Hopefully that makes sense. Oops. Excuse me, I'm about to sneeze. Tis the time of year. Alright, so let's see if that fixed things. That would be nice, wouldn't it? Okay, so good there. Good so far. Except for I would have hoped that it raised those up into the next grid cell. So this is 0.1825. Yeah, it's not enough to divide them by 4. Because that'll only be 0.25. It might be enough to make them up this, so we'll check that next. But we're going to get blocked again. So same reason. Basically, for walking up these ramps, dividing again in half, but basically dividing vertically by 4 is not enough, because we still get quantized into those same layers. So let's see if she would make it up here, though. So step, step. Okay, so see, I would have still hoped. Okay, she is trying to go up. But again, it didn't go up another block. Oh, I know what they're making downstairs. They're making hard-boiled eggs for Easter. That's what I'm smelling. Stuff cooking off the stove. Yeah, so Yeah, so she, again, it blocked here. So let's make it a smaller. What do we do? Want to divide by 8. Let's try it. Doink, 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 doink. Okay, let's see if she will find up here now. Whoop. Come on, come on, come on. There we go. Oops. Oh, because it's so much more granular. Actually, that is right, because it can actually get halfway into the block now. Alright. Let's see what happens, though. Step. Step. Yeah, step. Step, 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 step. Yay! Look, she can go up this one. Okay. Now, she won't actually be able to walk it once she finds the path, but she can try. See, she can't walk up there. But she's going to try. It did path it up there. It did it in a weird way, though. Like, I don't know why it had her go horizontally there. That's strange. Like, and a diagonal. Yeah, why did it do that? So it did step up, but it stepped up in sideways. And that makes no sense, because that's actually farther away from the endpoint than just going straight would have been. She's making it. Like, it's taken her a bit, but she's trying. Oh! Don't backslide, Mythruna girl. You can make it. Oh, she's gonna make it. Yay! Good job, Mythruna girl. All right, let me reset her. I don't think she's going to be able to make it up the other. It could be that vertically we just can't quantize at all, which would be fine too. And yeah, quantizing that way, especially vertical, is going to be weird for anything that can move, like, actually, anytime we have objects we can stand on, it's going to get weird. Problem for another day. Let's get one thing working first. So let's not arrive. Let's warp to here. Path to here. Step. Step. Oh, it went up. Step up. Couldn't make it. Could not make it. Yeah, similar problem, but I think it did raise them up, but not high enough. What if we don't scale at all vertically? What happens then? That would be like if we just had a really high number here. Like, now I've divided the blocks vertically into 256 layers, which means it should be pretty accurate. Just to see if we had just not done math on that at all, if it would be better. Yeah, first of all, we're going to get plopped right exactly where we did it. Yeah, same with here. We're not raised up out of the ground. Yep. Oh yeah, she'll make it right up, no problem. Of course, she won't be able to walk up there. Right, she's going to get stuck. Okay, but that's fixed the problem. So I'm going to call that good. Let's see if it messes with the stairs. Because there was a reason I did all that. Easiest way for me to clean this is to just reset. Okay, so that's one problem done. Let's see if we created more problems for ourselves. We want to path to... Oopsie. Yeah, that's the thing, is it collides with itself, so when you're trying to place that... Alright, now I want to path to more towards the center of the block. There we go. Alright, step. Oh, I need to change the iteration counts. Okay. I'm going to add a to-do item for myself. Add a camera recenter action. That would be so useful. Okay, so let's see if she can walk that. Yep. Okay, so we didn't break the old pathfinding any more than it was already broken. And here's an example of where I think that if I made it more expensive to step up diagonally, she would have tried to step up straight. Same here and here. So she should not be doing this kind of thing. Really, she should step up here and then step up here. This is already going to be smoothing things out. It only gets worse. But that's the stair problem I was talking about that I thought I was going to see here, but I don't like that she tries to walk up this step diagonally. Especially when it gets to the point where we're animating that step up, she needs to be targeting right here. So can I make stepping up a little more expensive? See where we set cost. Okay, so right. So if we're going up at all, it always costs a little bit more. But what if we scaled it? I don't think this is actually going to change anything. We want it to be more expensive going diagonally, and I just made it more expensive in all directions. Let's go back here, path to here, path to here. Step. Yeah, still she wants to go diagonal. So we need to make it more expensive diagonally. And just cost multiplier, it's supposed to be more expensive diagonally. Cost multiplier is 1. It's going up. Base cost for the direction is already going to be higher. So the fact that we've made that even more expensive . Yeah, I'm not going to get deep into this. I will play with this another time. But I need to make it more expensive to walk up diagonally so that we avoid those situations. I mean, sometimes that's the best way, but alright. So now, we got one thing done, right? She can path up hills. Let's see if she can path up this hill. I'd actually prefer if she couldn't. Whoops. So let's put her over here and try to path to here. Can she do it? Nope. Already failed. That's good. That's a special kind of pathing. That's climbing. And so she won't quickly get it. She'll eventually figure out that she can walk up this ramp over here. But an iteration at a time, it's going to take us forever to do that. So that's all working. Now we just need to make it so she can walk up the thing. So that's back over in this code. And it's going to be different than the regular step up stuff. Because eventually that's going to get replaced. But walking up a ramp is something that through regular physics forces a mob should be able to do. A monster should be able to walk up a ramp. So we shall run that. Alright. I think I turned off a bunch of stuff. Am I going to need it? I probably do want my probe shapes back. Okay, so we got our... When it only had... so there was a period of time where it only had the two down here, and I thought it looked a little too phallic, and so it's a little better that it's got a big box under here, but I still think about that. Granny needs a cinder chair. Yeah. Okay. Alright. What do I need to do? I need to detect that we are walking up a hill. That is going to be in this near avoidance contact stuff. So these are the ones... This contact avoidance is the one attached directly to the body of the player. And so when we detect the ground, is it considered a step at that point? Or just something we can walk up? We do need to keep track of our ground contacts. Okay, so new contact. This is we hit something. If it is up facing and it's in front of us, we calculate the relative y that we don't use for anything. We check to see if it's closer than any of the other ones we found. So does it come through as a step, I wonder? Can we debug closest step? What I want to do is in the steering function. Yeah. Closest equals closest step. That's fine, but let's print what the closest step is. Should be streaming out a whole bunch of crap. I guess not. Alright, pause the simulation. Arrive up here. And come over here. Step. One of these should hit. Yeah, okay. No, we're doing the cast thing. Why are we not printing closest step? Did I make a mistake? Let's make sure it compiled okay. It did. Simulation. Pause simulation. Arrive up here. And then step. Zoom simulation, yeah. So you need to warp over here, Mythruna girl. And then you need to arrive over here. And then we'll pause the simulation, and we will arrive up here. Then we will step, and let you turn around. We'll get really close so we can see everything that's going on. There we go. Why did she slow down? She slowed down. She is hitting those. Why are we not seeing the contact? Am I... Step. We're getting contacts there. I'm not sure why I'm not seeing them. Maybe I have it turned off. Nope, show avoid contacts. And the thing is, we are not even seeing, for one thing, so avoid contacts. Aha. So what if we add the contact even here? Except for we should be anyway. We get the contact, we do all the things, we come here, we should be adding it to avoid contacts. And it's just really bizarre that I'm not seeing any of the printouts I expected. So let's try again. Zoom simulation. Let's warp you over here. Pause the simulation. Arrive up here. Step. Yeah, see, I'm not seeing any ground contacts at all. So something's happening. The code I think is running is not running. So let's just double check, right? Kilroy was here debugging. We should be getting all kinds of streaming now when we resume. Right, we don't even see a single new contact. Yeah, okay, there we go. We saw them. but we're not seeing them here. At least I think we saw. I saw a bunch of output. Yeah, so I'm seeing new contact. But why aren't we seeing it? Why aren't I seeing any contacts? Oh, we pre-filter these. In the regular, like the contacts that the physics engine gives us back, we're pre-filtering them. I wonder if that's screwed up. Yeah. We don't send on the ground contacts. So here's where we're checking to see if it's an up-facing contact, and so this is a ground contact and we're ignoring them. So now we should see all kinds of resume simulation. We should see all kinds of ground contacts. I'll let that log catch up for a second while I delete this. So we kind of still want to and that's interesting. Upness over up threshold. What slope can the creature stand on? About 45 degrees. Yeah, it's 0.712 or 21, whatever. If upness is less than the threshold, this is not something we're standing on. We're either sliding off or it's a wall. And so we send it to the near avoidance new contact. What we really want to do, if front is less than 0. Oh, if it's facing into us. That's what that's doing. And then what we want to say here, let's call this new ground contact. And then up here, I don't think I need to. Yeah, it's a separate thing. Okay. So we've got a new ground contact. Let us see. Let's debug the ground contacts. So we're only 15 minutes into the second hour. I think we can knock this out. So we've got a void contacts. We want to also have ground contacts. And everywhere we do an avoid contacts, we want to do something else. So we'll add it there. In here, we'll change this to, we'll make another one, and we'll say show ground contacts, and we'll reuse the same or show ground contacts. Need to make my flag up here. Okay. So down here, ground contacts. Boink. Boink. Contact entity, blah, 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 blah. Contact. Ground contacts. What color do we want the ground contacts to be? Orange? Orange is a color we have not used yet for much. Okay, I think that should do what we want. Resume simulation. Okay, so yeah, we've got one ground contact here. And so let's see, if we pause the simulation and we try to arrive up here, I just want to see what kind of ground contacts we have. So we turn, yeah, so we've already got one here, right? And so, as we step, that's going to be even more, oh, we're not removing them. Uh-oh. Right. We're adding them to the cleanup entities. We're adding them to the contact entities. Why aren't they getting cleaned up right here? Show ground contacts. Contact entities. Cleanup entities. That's problematic. So what we want to do is we want to detect contacts in front of us that are higher than our current level and at an angle that we can walk up, and we want to use that to make basically a motion up relative to, basically we want our force to be forcing up instead of straight. But I'm a little concerned that we're getting all of those contact entities getting smeared. We removed a ton of them. They should be getting removed every frame, and I don't know why they're not. Right here. If any of these are true, we clean up all of the contact entities. And we're definitely adding them to contact entities. Weird. Oh, we're not clearing the we're not clearing them after. So basically we were building up the contact list over and over and over and over and over and over again. So we're just rendering more of them each time. Alright, resume simulation. Okay. I want you to warp back over here for a second. Okay. How to explain what I think I want to do. It gets squishy. Can I draw it? Let's say we're looking down from the top and she's facing this way, right? And there's a ramp in front of us, going like this. And so we get a contact here that's facing up and in our direction. I want to detect that to say I'm going up, but what I don't want to detect is a similar case. Whereas if I'm here, oops, and facing in this direction and happen to glance into this, I don't necessarily want to step up. So the amount of force I apply to stepping up should be dependent on how much that arrow is facing in the opposite direction of that I want to go, right? So if the arrow is facing in the XZ plane directly against me, I want to apply more force. If the arrow is facing not very much in my opposite direction, then I don't want to apply much force. And so this is the case for a dot product, right? Because the dot product will tell me sort of how similar these two are. In this case, they'll be like -1 if they're exactly facing each other. But the other side of it is that from the side, if I'm walking up, if I'm walking this way, and this is facing up, so if I already know I'm going to be doing this, then depending on how steep this arrow is, if it's pointing not very much to me at all, I don't want to apply much force. A little bit, but not much, because I'm going up a shallow hill. Whereas if it's a steep hill like this, and the arrow is pointing almost directly towards me, again, it's a similar situation to here, right? I want to apply a lot of force in this direction. So if it's so these two combined give me my upward force, and they're calculated in a similar way. And the neat thing is, like, if we use the dot product, so this is a similar, I'm going to draw the picture like this, right? We get either we've got one that's barely glancing us, or we've got one that's, you know, directly going against us. We want it to be bigger here, big, small. It keeps the internet lag keeps small. Okay, so that's for either of these, right? For this one, we want it to be it's actually the opposite, right? We want this one to be big and this one to be small. But it's the same problem, right? If you rotated this, it's the same problem. So if the dot product is high, like not very zero, we want to add force in this direction, and if right, and if the dot product is same down here. So we want it to dot with I'm just trying to think if we can just dot the two vectors together. Right, because I'm actually not moving in this direction. I'm trying to move in this direction because I have my thing I'm trying to go to up there. And that's always going to be the case for pathfinding, because we always path all of the parts. So I think I still need to do... I'm just trying to think. In this case, the direction I want to go is 90. Yeah, it's complicated, right? I think I need to do these two separate. It seems like I could do them in one vector, but I think I need to do them separately. Just trying to think. Because this is like when it's 90 degrees, that's when we want to, like, yeah. It's not, though. It's not that. We almost don't care. It's just, see, it's very tempting. Alright, let's do these separate, because I know that I can do interesting things with that. And that means that we need to accumulate a force, sort of. When we get one of these in, we want to see my direction in XZ. And then basically how steep the slope is. how steep the slope is relative to the direction I'm trying to go. Alright, let's first consider so the dot is my direction, dir, whatever the contact normal is. I prefer to deal with CN and that's okay. Like 3D CN equals contact. I think it's called contact normal, and this is why I like to abbreviate it. Nope, I've screwed something up. Yeah, I left this open. I just want to see if it's going to compile. Yeah, okay, cool. So CN. And that is not really the XC dot. That is just the dot against, yeah, it is in a sense, because dir is done in just the XC plane. But the contact normal is not, so we want to clone this and set its, so now we've just got a dot in the XZ, and we want to see how steep that is. And so that's the same dot though. That would be, so that's not, that's XZ contact normal. And so if we made another dot, you're going to see why this is tempting. I'm thinking of the vertical part now. My vector's facing this way. If I dot it with the one with the actual y value in, I don't actually care about any of the components except for my x versus its y, essentially, or my x against its x. But the x is some kind of inverse of the y in this case. All three components are all going to add up to 1. You know, if you square them and take the square root, so on. Anyway, I'm not going to get too wrapped around that. There's a way to simplify this math. I think I could do it in one dot product, but again, my math brain gets stupid. Dir dot cn, and let's just see what these look like. Print line CNY dot XC dot XC dot. And the reason I'm printing the contact normal Y is because we'll be able to use that to detect which of the many possible ground contacts we're seeing in the log. So yeah, we're seeing lots of them. They're all facing straight up, so we don't get any dot products. That's what the CNY stand 1.0, 1.0. And so now if we pause the simulation And we try to arrive up here. And we step until we get that first. Boink, 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 boink. Come on, step on the ramp. Boink. Did we get one yet? Oh, no. There we go. Okay, so we've got one down here. We've actually got two. It's interesting. Oh, I think because there's a collision shape here, and there's a collision shape for the foot if we show. So we're getting one for each of those. Okay, so we got, yep, so that's about what I would expect for a 45-degree angle. That's what I was saying, 7.07, sort of the Y value. And so, yeah, so we got it facing into us. And you see see these values are the same. Did I screw something up? I wouldn't have expected them to be the same, to be honest. Oh, because I didn't renormalize. CCN normalize local. Ah, they would be different. Okay, resume simulation. Warp to here. Yeah, I've got the clip plane set really far out so that we can see better. That's why things look weird sometimes. Okay, so step. Please turn fast enough to avoid the wall. Actually, I could have warp pause simulation. Okay. Yeah, so step a little bit more. There we go. All right. Yeah, so it's like facing directly into us in the XZ plane. But the reason that it was tempting to just do it in one is because I could, if this was not a 45-degree angle, then those two values would have been different. I could have potentially done a ratio between the two. I think that I need to work the math out on paper, but I'm pretty sure that I can do it in just one dot product. Maybe it would be better, as an example, if I showed, because I gotta actually, once I normalize, I gotta make sure that I can first. So let's do the shallower one. Maybe it'll be a little clearer. Oh, resume simulation. Warp to here. Okay, and let me turn off this normalize. Right, and then we will pause the simulation. We will arrive up here, and then this is where the centering would have been good. Okay, then we step. Oh, not that step. This step. Too many steps. All right, so we should get a orange. I think we got it. Yeah. We do. It's right there. No, so right. Right, I'm going to get the same dot because I didn't renormalize. I think I can just do one dot product. Anyway, so if XCCN length squared not equal to 0, okay. Resume simulation, pause simulation. We should be already seeing a right? So yeah, it's facing directly into us. Ignore the sign. It's actually completely backwards. But it's a shallow, whereas the other one was like 0.7 because it was steep. This one's 0.4 because it's not as steep. But it's taking direction into account, right? If we were doing a glancing blow, this would still be, no, it's still going to be smaller. I think this is okay. If we've got a big number here, it's facing us. So that's the influence of that. And if we've got a bigger number here, we also want to, yeah. So I think we want to say, we just want to have a up force equals 0. And we want to set that to 0 every time we reset. And then we want to calculate a new up force here. New up force equals math.max 0 xc dot. So if it's in front of us, negative xc dot, because it's always going to be negative, times the other one, times the regular, same thing, max 0 minus dot. And because I've done this, this means that there is a relationship between these two where I could factor all this out. I believe into one dot product. It doesn't really matter, dot products are fast, but so if the new up force, frost force, is greater than up force, then up force equals new up force. Okay, so now we have an up force that we can, in our steering equation, if we're moving forward, if we don't have a step, we're going to steer, and we want to add an up force. Whoops. And we might need to multiply that by something, because I suspect that 1.0 is going to be high. But let us see. Resume the simulation. Okay. Alright, so only when we're steering does this come into play. Let's see if we can arrive up here. Nope. Maybe we need... I mean, this isn't really working like it's supposed to. So I'm going to log the up force. Warp to here. Then arrive. Actually, let's cancel. Pause the simulation and arrive up here. We want to see what that force is. So let's bring this up over here. Step, 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 step. I have 20 minutes to make this work. Okay, we don't see any up force. Why don't we see any up force? Because... is this being detected as a ground contact? No, I don't have any of those being shown. I bet we're getting a climb. Am I in probe? No, I'm in contact avoidance. That's fine. no, because I'm steering away. No. We're not going to steer away. We're going to climb. Right, this is contact avoidance. Yeah, so I can't put it down here. This is how I'm trying to get around the thing. Let's resume the simulation. Alright, so you're all good. Pause the simulation. We're getting up force there. And so, if up force is greater than 0, we want to do some special stuff. Move y equals up force. And return true though, right? We want to use the update body. Where are we doing it? We always calculate the steering there, so it's fine. We will always set it. But so move, set, move. I feel like we were already trying to move up, and probe movement input is what we want to set. And alright, well let's try this, because we're doing it for climbing too. I think it's not right. But let's try it. Okay, resume simulation so everything goes, then arrive up here, and step. Just checking out that up force. Yep. Okay, we get an up force, and we are walking up. Look at that. Are we staying on the ground when we do it? Well, we're kind of bouncing, but it's working. Okay, what I'm curious also about is if she's going to do a little hop when she gets to the top. Yeah, she's floating, so probably we need to divide that force a little bit. She's moving up too hard, and so she's gonna like do a little jump as she gets to the top. Nope. So maybe that's okay. Alright, so let's see what that looks like in regular motion. So if we warp her back down here, and we arrive up here. Yeah, she's a little too happy. So let's warp her down here. See if she can arrive up the steep one. Yeah, so she jumps way too high. We need to, I think, probably square it, or do some factor. Let's try half as just a random, let's get it to look right. I'll worry about the details later kind of hope thing. Okay, walk it up the thing. Alright, she can walk up the ramp. Warp to here. Now arrive up here. Okay, so that's better. I think that probably, let's try up force times up force, which would basically, we've talked about this before, but squaring something is a good way to take a function that looks like this and turn it into this, right? When it's 0 to 1. when 0 to 1, it will make it like curved like that, which means less influence on lower slopes, and steeper slopes it'll have a higher influence, and so on. Did I save? Let's assume that I have now because I just did. Alright, so let's warp back down here, see if she can still walk up the steep step, or the shallow slope. Yep, actually it looks alright. Let us try the other one. Arrive. Whoa, nope, way too much. Like she just jumped right up the thing. And now she can't get down there. Oh yeah, the thing I didn't talk about. The thing about not walking off the edges. So watch, if I make her go over here, she's going to automatically path around that just because she's steering away from the edges. So if I have her arrive over here, like she walks around the corners. Right, so that's kind of cool. That's what those things down here do for me. Alright, so we need to make this, well, let's warp over here. Let's make sure that whatever we do, so what was the up force? Let's like, yeah, let's actually look at the maths because we can do everything directly anyway. So we can pause the simulation, we can see every little aspect of this, and then we can step, and as soon as she gets to there we can see what the up force is and what squaring it would have done. Because there's an inflection point where it starts to get higher, and so if we were already at like 1, okay, so the up force is 0.7. Yeah, so when we squared it, it went down, so that would be fine. But then, for whatever reason, that's a big force. And so she just kind of floats and then keeps flying right up. Right, so, yeah. So let's try doing this. Boink. Resume the simulation. Boink. Whoa, hello. Yeah, that's the other thing, is it needs to be based on whether she's actually moving in that direction. So where I'm doing this, how much force do we apply, direction stuff, this really needs to be the direction that she's trying to move, which means I need to accumulate sort of the maximum, the vector that would have the most effect. Instead of calculating the up force here, I need to calculate the up force down here based on how much it's already trying to move in that direction, this default move. Like if she's not, anyway, not my direction that I'm facing, but the direction I'm trying to move, which are not necessarily the same thing. Up force times up force. We did this, and now we want to see warp down here, arrive up here, step. It's cool we have that up, and away showing me the value that it's actually going to turn into a force. Okay. So up, and away gets really small. Can she make it up with that? Yeah, it looks like it. Yeah, this is actually not bad at all, right? She looks like she's walking up the hill. The feet don't even slide too much. That's not too bad. I mean, they do, but I'm just saying if she had an animation where she was stepping up that's at the same pace as the walk animation, it would have been alright. Alright, so let's see what that looks like in actual fast motion. Yeah, it could probably be a little smaller, but let's see if she can still get up the shallow ramp. If we make the forces too small, yeah, so she can still get up the shallow ramp. Maybe we don't need to be squaring that. I would actually like her to walk up this ramp like that. Gosh, I hope there really are 7 viewers on watching my successes right now. Okay, so 0.7 times 0.7 got us... where's my oh, I don't have a calculator. I had to reboot the system. So let's just 0.7 times 0.7, guys, like 0.49. Yeah. And then times, am I taking half of that? Yes. So what I really want is no longer to square this, but I want to have the same value ultimately for the up force, which means that if I want this to be 0.701, what do I have to multiply? Oops. Whoa. 0.49 times 0.5 equals divided by 0.702, something like that. 0.349. So 0.25 should actually be even better. Okay. So let's warp her back down here. Arrive up here. She walks up there jauntily. Alright. Warp down here. Arrive up here. Yeah, too much. I think we need to just make it a maximum. So math.min, whatever is smaller, that or 0.34, let's say, just as a random, pulling it out of my rear. I don't even know if that's what the value was. I get ahead of myself sometimes. I could actually look at the numbers and calculate what would be a good value. Yeah, she's still. So what were the numbers there? The up force was 0.2, up and away, already too small. So let's see what it is. 0.175 is what we're getting at there. So let's warp over here. This actually looked really good, so I don't want to affect this too much. So let's see what the max was here, or what the value was here. Pause the simulation. Arrive up here. Step. Okay. 0.44, it turns into 0.1. So let's make it like 0.15 maybe. Alright, you finish your walk. Oh yeah, it would reset. Okay, so you finish your walk because I want to see it. Yep. Yeah, I actually think that's still too much. So probably I could make this even smaller. Let's try 0.125. And warp here. Arrive up here. Can you still walk up the path? Yes. I think that looks alright. Should go a little slower going up hills. Alright. But I think something is inverted, right? Because she's getting... It may be that it just needs to be a constant force. Because she should walk slower, even slower up these slopes. Yeah, that's pretty good. She is. That's not bad. Alright. So let's do let's do fancier stuff. Now that we've got that working and it's almost time for the thing to end, let's warp her down here. Let's see which path she will take if I say path to here. And then we step. Oh, nope, not going to do it. Where's my iterations? Iterations back to 10. Way cooler that way. Okay. So we want to path to here. Now step. Yeah, see, doesn't that look cool? Okay, so she went right up there. She's bypassing it all. Oh no. Because it's not quantized anymore. Shoot. She can't detect that that's the end of the path because it's she made it up there, right? So path to here. Like I think that Like she'll never actually make it there. Step, 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 step. Yep, she did this time. Okay, but there is an issue there where now that I've made Y to be anything, I need to change sort of how close she has to be to that before it considers done. And this is wrong. Yeah, so there's something in the distance math that's broken too. But she should be able to walk that path, and it should smooth it out for us. Yeah, so she can get up there. I'm disappointed. Yes, you can't actually get there. I mean, there are issues to work out. Yeah, so something's wrong here. If I warp her back down here, path to here, path to here. All right, step, 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 step. Okay, she found her way up there. Let's see if she can actually walk it. Yep. She can go up ramps now. Yeah, so the end detection is all messed up now because it's expecting to be... Oh. Is it still pretty noisy? I only just saw that message. The sound's still pretty noisy. I wish I had timestamps on these messages. So if the sound is still pretty noisy, please indicate. I'm going to see if she can walk up this ramp. I'm hoping no. So let's clean the path. Warp her down here. It's still noisy? Oh no. That's not good. Okay, see what I can do. Yeah, can I listen to it myself? Let's see, this is me. Can I hear it what it sounds like on my end? Oh yeah, quite a bit of quite a bit of fuzzy. That's weird. I don't. It's weird to hear myself in echo. I apologize for that. We're almost done. So let's finish up this last test. I really apologize for that. I hope it's not endemic of, I hope there's not something permanently broken. Alright, let's see if we can walk up here. I hope not, actually. Oh, we can. Oh well. So I need to check the thresholds to make sure she can't do that. That's actually probably the regular step up stuff that's doing that, which already needs to be fixed. But in general, things are working. Let's get her to walk all the way over here with just the arrive. See if she can do it. So no pathfinding. It's just normal, trying not to fall off the edge stuff. She made it over there. That's pretty cool. Audio's okay again. Of course it is. Awesome. Excellent. Yeah, so that was really weird. I think that's OBS. I can't imagine what else it would be. Okay, so that was pretty cool. She actually walked that whole thing. Just with the arrive behavior, no pathfinding at all. She avoids walking off the edges. That's pretty cool. Like that's not, yeah, that's cool. That's not even with pathfinding. It's just the same thing she uses to avoid walls. So pretty cool. Oh, here's the other thing we never checked. Will she be able to go down hills? Step. Oh yeah, she went down the steep one. I don't know. So she won't go down this one for whatever reason. That's a problem. But will she walk it? Yep. Oh, no, so the same thing that's trying to keep her to walk off the edges makes it hard for her to sometimes walk down the hill. So there's some tweaking to do, but essentially this is working, right? She would look janky trying to navigate the world, but she can navigate it. Yeah, so she's trying to avoid falling off this edge. Yeah, that would be nice. If I could make them do parkour, you could have some really cool enemies that way. Like some ninja thieves or whatever. I'd just be happy if they can walk up and down stairs and, navigate around a town, personally. The dungeons are all pretty flat, so already the 2D pathfinding would work for dungeon mobs. But I really want to bring the towns to life with having the NPCs have daily routines and things and be able to wander around, find their house, go to bed, that sort of thing. All right, I think I met all of my goals. I believe. We can pathfind up the ramps. We can walk up the ramps. Those were like my minimum goals. So that's pretty cool. All right, any last questions as I wrap it up? Because it is 11:02. Thank you all for joining. Oops, that's not what I want. I want to hit here. Thanks for joining. Please leave a comment if you like, or subscribe, or thumbs up, all the things, like, comment, subscribe, etc. Thanks for watching. Thanks again to my patrons. And if you would like to become a patron, that's the link right there, PSpeed42. Even if you just want to follow, join as a free member, that's pretty cool too. And again, I'm going to turn off that music so you can hear me talk. And again, so join the Discord. We have some interesting chats there sometimes. And I will see you guys next time. I don't know exactly what we'll be doing next time. Probably the next extension of this. Maybe we'll get into AI. We'll see. Thanks for watching.